That's a measure of momentum. Effectively, it's a measure of how much movement there has been in the top layer of the Earth and what size has moved. So the Earth's crust is split into lots of different plates.
March 22nd, 2025. A powerful earthquake slams into Myanmar. But what shook the scientific world wasn't just the quake. It was what happened before. An anomaly, subtle, unexplained, and detected weeks in advance. Not by human scientists, not by satellites, but by a quantum-powered AI system. And now, NASA has confirmed it. This wasn't a false alarm. This discovery could mark the beginning of a new era in how we predict and potentially prevent earthquakes. So, how did AI detect the disaster before the first tremor hit? And what does this mean for the future of Earth science? Let's break it down. The shock wasn't just the earthquake. It was the fact that a quantum AI system built by NASA and international partners had flagged Myanmar as a risk zone weeks earlier. This isn't ordinary AI. It's powered by qubits, the foundation of quantum computing, which can process incredibly complex, chaotic data faster than anything before it. Where traditional systems look for known patterns, quantum AI hunts for hidden anomalies, the subtle magnetic shifts, microcrustal tremors, and gravitational distortions that no human or classic algorithm could piece together. And that's exactly what happened. The system picked up warning signs, shifting tectonic pressure, magnetic field pulses, gravitational quirks, all pointing to an impending event. When those predictions aligned with real-world seismic activity, NASA took it seriously. Scientists began receiving live updates as the data evolved. And they quickly realized the quantum AI wasn't just accurate, it was ahead of reality. This marked one of the most advanced earthquake predictions ever recorded. This isn't just a breakthrough in AI, it's a moment that could change how we respond to natural disasters forever. If this kind of next-level science blows your mind, hit that subscribe button. We cover incredible breakthroughs like this every single week. Now, let's zoom out for a second. For decades, earthquake prediction has been one of science's biggest challenges. Tectonic plates move in ways that are often chaotic, unpredictable, and invisible, until it's too late. Even the most advanced seismic systems struggle to warn us in time. That's why quantum AI is such a game changer. It doesn't just look at surface movements, it dives deep into data layers that would take traditional supercomputers years to analyze. It reads Earth's behavior like a code waiting to be cracked. NASA's decision to apply quantum computing to seismic forecasting is part of a much larger shift. From space missions to environmental risk modeling, quantum systems are pushing boundaries we never thought possible. But this moment, this quake, might just be the turning point. Not just for how we see earthquakes, but for how we understand the Earth itself. First major theory: a shift in what we thought we knew. So, what does all this mean? If AI can detect seismic events before they happen, are we on the edge of a scientific revolution in how we understand earthquakes? The first major theory? This isn't just about tectonic plates grinding against each other. Some experts now believe that the Earth's crust may not be the only player involved. The quantum AI system picked up disturbances not just in seismic pressure, but in gravitational fields deep within the planet. That suggests something entirely new. An invisible force or unknown geological layer influencing seismic behavior. For decades, we've assumed earthquakes come from stress building along fault lines until something gives. But what if there's more to it? What if massive hidden structures below the Earth's mantle are impacting how and when these earthquakes happen? This theory could reshape everything we thought we knew about geology. And then there's the magnetic theory. Quantum AI may have also picked up minute shifts in the Earth's magnetic field, possibly triggered by cosmic events. Could space weather, solar winds, or even shifts in the magnetosphere be subtly pushing tectonic plates out of balance? For the first time, scientists are asking, is space messing with the ground beneath our feet? Twist. Signals from space? But here's where the mystery deepens. As NASA dug into the quantum data, they found something that didn't make sense. Not just tectonic patterns or magnetic distortions, but signals that didn't even originate from Earth. Some of the seismic signatures appeared to be linked to external cosmic sources. Yes, you heard that right. The signals might be coming from space. Could Earth's crust be reacting to gravitational waves from distant cosmic collisions? Maybe even supernovae, or black hole mergers that happen millions of light years away? If quantum AI is sensitive enough to pick up those disturbances, we may have just uncovered a hidden relationship between cosmic events and our planet's most devastating natural disasters. Suddenly, this isn't just about geology. It's about astrophysics, quantum mechanics, and the mysterious forces that tie the universe together. If you're still watching, you're officially one of the curious ones, the ones who want to know what lies beyond the surface. Tap that like button and tell us in the comments, is this AI revealing signals from higher dimensions, a glitch in the simulation, or something we haven't even imagined yet? This isn't just about earthquakes anymore. It's about the unseen forces that may be shaping our world, forces that could connect the very ground we stand on to the farthest reaches of space. Are we detecting the unknowable? Now here's where things really break open. Some scientists are asking the unthinkable. Could quantum AI be detecting something that exists beyond the 4 dimensions we experience? We're talking higher dimensions, parallel realities, and yes, even simulation theory. If quantum computers can process information across entangled states and probabilities, could they also detect anomalies in the very fabric of space-time? Some experts believe we might be seeing the first digital fingerprints of a multiverse, or another layer of physical reality we can't yet perceive. There's also a more grounded but equally fascinating idea. The AI is picking up on natural processes we haven't discovered yet. Maybe there's a new class of seismic activity influenced by quantum fluctuations in space-time, a kind of background noise in the universe that's now just loud enough for quantum systems to hear. If that's the case, we're not just predicting earthquakes, we're listening to the heartbeat of the cosmos itself. And then came the jaw-dropping twist. NASA has now confirmed that the anomaly flagged by the quantum AI wasn't just a fluke, or even just a new kind of seismic signal. The data reveals something far more profound, a pattern that doesn't stop at Earth's crust, but stretches into the very fabric of space-time itself. That's right. This wasn't just an earthquake prediction. Quantum AI may have detected fluctuations in the quantum field, the invisible energy grid that underpins our entire universe. In simple terms, this anomaly might be the first measurable link between our planet's geology and the deep, mysterious forces that shape the cosmos. Some researchers are now daring to ask, are we witnessing a fundamental shift in how Earth interacts with the universe? Could quantum fluctuations, ripples in space and time itself, actually influence our planet's seismic behavior? This changes everything. If true, it means we're not just studying earthquakes anymore. We're standing on the edge of a new science, a new frontier, where Earth's deepest tremors may echo through the universe, and the universe may be whispering back. The earthquake that struck Myanmar on March 22, 2025, was a wake-up call, not just for the region it impacted, but for the entire scientific community. While the world saw it as another devastating natural event, hidden beneath the chaos was a discovery so profound it may reshape our entire understanding of how our planet functions. Thanks to the unprecedented sensitivity of quantum AI, this event has become more than just a headline. It has become a defining moment in the history of Earth science, a moment when we moved from reacting to natural disasters to possibly predicting them with never-before-seen precision. A moment when science began peering into not just Earth's crust, but into the very code of the cosmos itself. For years, earthquake prediction has remained one of science's most elusive goals. Despite countless advancements in seismology, researchers have continued to struggle with the unpredictability of tectonic movements. Traditional models rely heavily on monitoring surface-level activity, pressure along fault lines, and historical data. But earthquakes don't always follow the rules. And until now, the technology simply wasn't advanced enough to catch the early signs buried deep within the Earth. But quantum AI changed that. Its power doesn't lie in faster computing alone. It's in its ability to detect what no one else can see: subtle shifts in gravitational forces, anomalies in magnetic resonance, tremors so small they escape even the most sensitive seismic equipment. This is a completely different level of observation, one that opens the door to real-time forecasting on a planetary scale. In Myanmar, quantum AI picked up on signals weeks before the quake ever struck. And when the event did occur, the match between prediction and reality wasn't just close, it was chillingly accurate. That kind of foresight could revolutionize global disaster preparedness. Imagine a world where cities get advance warnings not hours before, but days or even weeks ahead of a catastrophic event. Evacuations could be organized, infrastructure could be secured, lives could be saved, but that's only the beginning. What truly shook NASA scientists wasn't just the accuracy of the prediction, but the origin of the anomaly itself. As data streamed in, it became clear that this wasn't simply a matter of shifting tectonic plates. The signals quantum AI detected appeared to align with fluctuations in the fabric of space-time, suggesting that our planet might be far more interconnected with cosmic forces than we ever imagined. That brings us to a staggering possibility. What if seismic activity isn't just a byproduct of internal Earth dynamics, but a response to external cosmic phenomena? There is mounting speculation that gravitational waves from deep space, ripples in space-time triggered by supernovae or black hole mergers, could interact with Earth in subtle but measurable ways. These cosmic events travel light years to reach us, but once they do, they may exert force on the planet's interior, triggering shifts we've never been able to trace until now. Quantum AI may be our first tool capable of identifying this relationship. And if true, it would rewrite the laws of how we understand geophysics and astronomy. It could unite disciplines once thought completely separate and create an entirely new field of Earth-cosmic interaction science. But it gets even more mind-bending. Some theoretical physicists are asking if what we're seeing are the first signs of higher dimensions, quantum fields, or simulation glitches in the structure of reality itself. Could these anomalies be revealing evidence of multidimensional influence? Could the Earth be responding to not just visible forces, but ones beyond the veil of traditional physics? The quantum computing systems powering this discovery are already brushing against the limits of what we thought was possible. So the real question becomes, if quantum AI can read the subtle whispers of reality, what else could it uncover? Could we be looking at the beginning of a new scientific renaissance, one that allows us to map the unseen architecture of the universe? From the deep Earth to deep space, the possibilities are staggering. This technology could one day be used not only to monitor seismic events on Earth, but to explore the geology of distant moons, planets, even exoplanets. Imagine predicting moonquakes on Europa or mapping the core of Mars before a mission ever launches. What we've seen in Myanmar could become the blueprint for how humanity studies planetary bodies across the solar system and beyond. And here's the bigger truth. This isn't science fiction. This is happening now. Quantum AI is no longer a concept. It's operational. It's analyzing data. It's making predictions. And it's uncovering new layers of reality we've never had access to before. If this discovery blew your mind even half as much as it did ours, smash that like button, subscribe, and turn on notifications. We cover quantum tech, cosmic anomalies, Earth science, and the frontiers of space every single week. And you're not going to want to miss what's coming next. Because if quantum AI is just getting started, then the universe is about to get a whole lot weirder. Stay curious, stay awake, and remember, sometimes the biggest discoveries happen right beneath our feet.